last year, I was accused unjustly of using a certain should not be named font that may rhyme with Comic Sans. It was not actually Comic Sans, it was chalkboard. But so I've been getting crap for the last year about my font selection. So to those people who are concerned about font, take this. This would be Curls, and I think it gives it a little something something. So, it does. And so this is Pig, Finding Truffles Without a Trace. I am Ryan, and this is CarolinaCon 7. So, yeah, it continues for a little while. So we're going to talk for a little bit about who I am and why we're here, how this is going to help you, and then I don't like slides very much because making them is boring, looking at them is boring. So I'm going to do a couple demos. We're going to talk a little bit about how the passive information gathering stuff works, and then we're going to actually look at a little bit of code for how to write the parsers. And then, so once we talk about all of the horrible things that may happen to you, we're going to talk about how to fix it. And if you think this stuff is neat, I don't have as much free time as I used to, so I could use some help making this cooler. So if people are interested, I'd love some help. So we're going to be talking about passive information gathering. A lot of the time when you hear passive information gathering, what people are talking about is using Google, using Maltego, and other sort of tools that go out and find information about you on the web, on Facebook, etc. And it's passive in the fact that it doesn't actually touch your network or send any packets or anything along those lines. So the concept behind this is, say you arrive on a network, you plug in, you log on to wireless. What information are you sharing about yourself by just nature of being part of that network? I'm not talking about, so say someone's man in the middle view or anything like that, but say you're just, casually on a network. What packets are you broadcasting out that are just screaming, hey, I'm here? So we're going to look a little bit about what type of information computers send out just by nature of them being part of the network. And we're going to look at some profiles for individual applications, and how we can look a little bit about different types of packets that networks frequently send out that help them figure out what their own network architecture is, how we can take those and abuse them. So we're also going to figure out, one of the things that I was most interested in is, and the way that this came about is, I was trying to figure out why something I was writing didn't work. So I put up my sniffer, and so I just started watching some of the stuff come in, and some of it looked really interesting. And so just by me being on the network, people were sending me stuff. It wasn't stuff that, I really needed to know about, like, who was running Dropbox and stuff like that. But yeah, they were sending it to me anyway. So I was like, well, what can we figure out from this information? So we're going to figure out some of that. One of the nice parts about this is it's completely silent. You don't have to send anything out to get these packets back. You just have to be part of the network. So this is all stuff that if you plugged into a corporate network would be information that you might be able to glean about the network. Or if a malicious person has captured one node, what they can get back from your network without stripping IDS sensors, without dropping 0 days, without custom malware. This is just by nature of someone infiltrating your network, whether it be plugging something in the wall or sitting outside Starbucks, looking at your wireless. So I guess there's a lot of reasons to be here. Just woke up and not ready for more beer, or haven't gone to bed yet. But the deep packet parsing, it is fun. How many people here look at packets on any kind of regular basis? Awesome. That's a lot more people than I expected, so that's going to be cool. Or you could have heard about pigs, and it's North Carolina, so I'm not going to judge. But we are going to be talking about stuff to look at on your network. And tipping your hand to attackers. So for sysadmins, this is going to tell you what kind of traffic you're transmitting and maybe how you don't have your host locked down properly, and in ways that it can improve. We're also going to be looking for pen testers how to use this information to gain strategic advantage. But for everybody, if you go to the airport and connect, you go anywhere and connect, you probably want to know what kind of traffic you're sending out and giving information about your stuff. So we're going to be talking about how to look at this information. We're going to be using Metasploit for this capture stuff. I've written some plugins to make this possible through Metasploit, so you're not going to have to be looking through Wireshark, clicking through packets to figure this stuff out. All of this is pre-parsed for you in a usable form. And Metasploit's database isn't necessarily beautiful as far as output. It is extremely functional. But what I did is I've souped up Dradis a little bit, which is a documentation framework that pen testers frequently use in order to pull data directly from the Metasploit database, shove it in there so that you can get a little bit more information about the information from the Metasploit database in a more readable format. And also, you don't want to be sending a lot of this stuff out if you don't have to. So we're going to talk about a little bit about how to stay a little bit quieter on the network. So, like I said, I don't like slides. So we're going to do a demo for gathering traffic, doing it with Metasploit. Then we're going to shove it into Dradis, and then we're going to talk about this guy, which is the Pwn plug. So I guess the other thing is, I kind of like comments and questions, etc. So if you have something that you feel is relevant and you want to add, if you have a question, feel free to interrupt. I have it scheduled to go a little bit short so that we can facilitate questions. Anybody have any questions up till now? It is not appropriate. So I guess the other thing I wanted to mention is we're going to be gathering some of this information. I have my happy little wireless connected. So let me actually go ahead and bring that back up. So let me connect this back to, or maybe not. So I was looking around earlier at the Capture the Flag network, and I noticed that there was actually quite a bit of traffic there. So one of the things we're going to be looking at is the people who are playing Capture the Flag, what information they were giving away. So first of all, Metasploit uses the Postgres database now by default. So if you need to create Postgres database, you want to make sure that Postgres is up. So, and in this case it is. And then you want to just create your DB. We already created a user called MSF, and you can just do that. So once you do create user MSF and follow that by your create DB, then you will have everything you need to go ahead and hook this up to the database. So we're going to be doing this as root because in order to do a lot of the sniffing stuff, you're going to need to be root. So the other thing is so you're going to be running a tool, which is a hacking tool as root, and so that can be interesting, just for the whatever it's worth. So to start Metasploit, I've created an RC file, and what this is going to do is it's going to load the XML RPC module, which Dradis is going to need to pull the data out of Metasploit. We're setting the password to test. Then we're setting the database up so that it will use Postgres, and we are connecting to it. So when we start Metasploit, we're actually going to see it initialize the database and bring all of our information in. So how many people here have used Metasploit before? Okay, so a good number. For those of you who haven't, Metasploit is a penetration testing framework that has everything in it from exploits to scanning, information gathering, and it makes both pen testing a little bit easier as well as creating tools for penetration testing and exploits easier because it has a lot of the functions already built for doing some of this stuff. So Metasploit already has capabilities in it to do PCAP, capture, sniffer type activity. So we don't have to do all that. So now we have our database stuff created. We can verify there's nothing in it. And so right now it is empty. So the module that I wrote is called Pig. It is in the auxiliary tree under sniffer and Pig. So this is not yet in Metasploit. I'm still trying to make this a little bit better before I hand all this stuff over. So it is in my Subversion repository, which you can look at the URL later in the presentation. So to look at the options, we can do show options. What we're going to do is we are going to use our PCAP file that I captured earlier. That was it. Sorry. Let me make sure that's actually the right file too. So we're going to set our PCAP file to temp cc.pcap. And so the nice part about Metasploit is you can really pull in lots of other information and use modules. The bad part is when you build on top of them, sometimes there's crap you don't want. So there's this rhost variable that has to be set. Okay. Yes, you can do this live. And I can, well, let me unplug this and plug it back in and see if that makes it happier. I slept my VM, which was probably not the best of plans, and so the wireless is being a little goofy. Let me see if that'll look back up. But so we could do this on the live network if we wanted to. Yeah, there we go. So let's connect back to here. Okay, so we're going to start off by looking at the CTF network, and let's unset our PCAP file. We're going to set our interface to WLAN 0, and then we just run. Apparently I didn't listen to myself. So it auto-loads a bunch of the modules for us. Each one of these is a different type of module. And so now we're seeing a couple of different types of traffic. We're going to see MDNS, which MDNS is interesting. It is multicast DNS, and it helps programs look for DNS-style information. It also gives away quite a bit of information. It did request a DHCP address, but right. So I have just requested an IP address. So if I didn't want to request an IP address, I wouldn't really have to. I'm using Bayes and Botu, and I'm taking the easy route. If I wanted to just associate with the access point and not do any DHCP style activity, you would still see me on your access point. Since I'd associated with it, but I wouldn't have sent out any packets aside from those. So we can see DHCP requests coming in, MDNS, and you wait for another couple minutes, and you'll see other type of broadcasts come through. So we can see from the information that we've gathered so far, and this is actually running in the background, that we have a host called Enigma that's connected. And we have some information from DHCP about one of the hosts that requested an IP address. So we're parsing all of this stuff real time. I'm going to go ahead and pull in some of the stuff from earlier. So this is the information that I grabbed earlier. So you can see here we've got Dropbox, we've got DHCP, and there's actually going to be a little bit more stuff here. So we can see additional hosts that were found and additional note information. And additional service information as well. So these are all of the ports that were discovered just by listening, hosts that were discovered, and all of this is just from listening to the network. Right, so all of this, basically I'm dropping everything here that is not broadcast or multicast. There's a couple things that don't fall into there, which I think that technically Cisco Discovery Protocol is multicast, but it's kind of one of the ones that is shoved in there in sort of an in-between layer. But everything that we're doing here is just broadcast or multicast traffic. So we haven't, I guess one of the other things to think about this, you see a lot of information out there about products which do passive information gathering. A lot of the time they're designed to sit at your core where you can span ports and have additional access. So we have no additional access here. We haven't done any sort of injection in order to be able to man in the middle anyone or anything like that. We're just straight up request an IP address, looking at broadcast and multicast traffic. And this is all traffic that is coming to us. So if you want to participate, you can connect to the CTF network and you can see what you're sending in real time. So I'll go ahead and leave that up. But there's a couple of things that Metasploit keeps track of. It keeps track of hosts, so as new hosts are discovered, it adds those to the database. It keeps track of services, and the services are related to hosts. So if you're interested in finding out more about what services are on a host, you can query the services table for a specific host. And then notes is freeform. The notes section is basically for and other data. The notes section is to store any kind of freeform information that doesn't fall into a service, a vulnerability, a password, or a host entity. So as you can see, all of these are basically Ruby hashes. And while that's really kind of interesting, that's difficult to manage. So the multicast information we're seeing is, that is one of the things that helps us populate services. So you'll see those coming up. So okay, so now we have some information, but it really kind of sucks to look at it like this, especially as the information starts growing. And so I'm going to leave that there. So in comes Dratus. Who here has used Dratus before? Okay, so Dratus is a documentation framework. And what Dratus is used for is keeping track of information about hosts, services, and all of this other information that we gather during a pen test. So we can pull in Nessus results, we can pull in Nmap results, and we can pull together all of this information to create a single source where you can click on a host and dig down and view information about the stuff. Dratus is a Rails application, which is makes it fairly transportable. It also uses SQLite, which makes it really not very suitable for very large scans. So as our scans get bigger, it may or may not be as useful. However, since we're using the Metasploit API to get at this information, you can actually write your own Python scripts or Ruby scripts to directly query the database for specific types of information. And so when I'm pulling apart things like CDP, when I record that information, I just pull it directly through the API and parse it there to give me just the information that I want. So Dratus uses a concept called Thor, which is a Rails management program which will let us do a number of different types of tasks. So a Thor list will give us all of the information about things that we can do. So we are going to do a Thor Dratus :server to start up Dratus. And it goes ahead and sets up SSL for you. And so now we have our Dradis framework brought up. We will want to import the Metasploit stuff. So we will go to configuration, and under this we want to look at the MSF information. So we're going to be connecting to localhost on port 55553. And the 55553 and MSF are the default values. I set my password to test when we loaded XMLRPC. So we set that, and everything here is good. So we can close this window and come back here and background this. So when we do a Thor list, we see a number of different things. These are all of the Thor tasks that we can do. One of them is import MSF all. So to do this, we just do Thor, Dradis, import MSF all. So this will log into the Metasploit database and suck all of the information out and delicately place it into Dradis. So we can see that completed. So this will take just a second to come back up. You can see we're still receiving packets, so we're now up to more hosts. Hi, Christopher. Oh, that was another one. So while I was playing around with this stuff, I was looking at what my own stuff was sending out. And so when you get your Mac, your iPhone or whatever, it's really awesome because it puts your name right in the name of the computer. So then when you go out into the great wide world, it tells everyone, everywhere you go, who you are. So if you're like in a Starbucks or whatever and you're testing this out, it's really creepy to just go, "Hi, Christopher," to the person who is sitting there, browsing on their iPhone. I don't know if that's stalking or not. I'm not a lawyer, so. So that is a couple of things, and one of them is MDNS, the multicast DNS. So this is still pulling in information. Bonjour does give you additional information. Bonjour is actually part of the multicast DNS stuff, and Bonjour is also what is responsible for telling you who you can steal iTunes from. So that is really, I think, where the multicast DNS stuff really picked up more recently, is with the Apple products and being able to, because when you're using a Mac, you want to be able to figure out where everybody's iTunes are, and there's some other more interesting stuff there, like there's a presence protocol. So if you want to know if somebody's actually in front of their Mac, the Mac will tell you, because it's helpful like that. Which is especially useful for pen testing, because if you're going to screw with something, you certainly don't want somebody shutting the browser down, or whatever you're messing with. So you want to know when they're there. Multicast DNS also gives away some information, like, hey, look at me, these are all my ports that are open, come touch me. It's kind of like ow. It's nothing but love. So that sort of information certainly is helpful. So let's refresh this. And so we can see now that the hosts that we'd talked about earlier are there. So let me go ahead and expand all of these and dig down in. And so we can look at the specific information that we found out about each host. So this isn't very helpful. So for almost all these, you'll actually have to double click. So we can see when we saw the host. First, the host is alive. For some of these others, you'll get a little bit more information. The multicast DNS stuff, those notes don't show up specifically. What they do is they add the different ports that were found, and include that information. So as we go through, we can see that this port is open, that type of information. I believe we're still actually pulling information in. Let me go ahead and it imports Nessus. Like I said, the other part of this is I haven't worked out all of the tweaks, which is the other reason it's not in Metasploit yet. So if you send really weird packets that are properly formed in one place and then are just crap somewhere else, this thing will vomit all over itself. Which was what this is from a DHCP packet that was malformed in some way. So. And we're still importing all of that stuff. So when we look back through here, one of the interesting ones is for the host information that we get based off of Windows broadcast stuff. We can actually figure out names and other information about. Let's see here. You can figure out the name of the host. You can figure out the domain. You can figure out a lot of other information in those areas. So I'm going to leave this for a minute and let it finish importing, and talk a little bit about the pwn plug. So this is kind of neat. This is a Linux box, and it's got a couple of different USB ports on it. It's got a network port, and properly labeled can probably go undiscovered for some long period of time. Something like CO2 detector, or put it beside the printer and somebody will think that it's some sort of printer accessory. Yeah.
They'll see where they can fly with.
But this is capable of running Metasploit, is capable of running many of the backtrack tools. So along with the wireless adapter, you can do a number of things here. One is you can run Metasploit on it, which will turn it into a malicious wireless access point, where pretty much most things that you might guess someone might be willing to connect to can be broadcasted out, and people can try to connect to it. Or if you plug a cable in and slap it behind a couch, it will actually try to tunnel back to you to get you information. So it will try to tunnel over SSH using HTTP, HTTPS, DNS, and will fall back to ICMP. So if there's a packet type that can leave the network, this guy will find it and bring it back to you. So all of this stuff is capable of running on this. And so where this comes into play is if you're doing a pen test, or if you're trying to prevent for something like this, you're worried about some bad guy coming in and plugging something into your lobby network and then walking away. This is the size of thing that you're dealing with. The next version of these is a little bit smaller, and they actually have 3G in addition to wireless capability. So you can have something that is sitting there sniffing wireless and has tunneled back over 3G back to the attacker to be pulling this type of information. So, and the guys that are selling this, it is the mini computer you can get a lot of places. But the guys at the Pony Express, PWNIE Express, are selling these loaded with basically pen testing attack toolkits, so that you can use those. It depends on, the price depends on what you're looking for. I think the one with just the Ethernet port is something like 180 bucks. Once you start going to 3G, I think it's about 250. So they're fairly reasonably priced. For pen testers, a lot of the time now, they're actually sending boxes a little bit bigger than this out because it's expensive to ship people around via planes. And so the same type of technology is what legitimate people are using to tunnel back in order to be able to do pen tests remotely. So this is sort of a logical extension of that. This is the pwn plug, and it is by Pony Express, PWNIE Express. And so anyway, so once the information's been pulled into Dradis, you can manage it all from here. In addition, so for the different other things that you can import, you can import lots of other external sources. So vulnerability information from the OSVDB, and you can even import different types of files. So from the files, these are all the different types of files. So burp, nessus, nexpose, nicto, nmap, any of the vulnerability scanners, as well as W3AF. So you can pull all of your pen testing information back into here once you've sucked in the Metasploit stuff as well. And so this will really help you build a profile for a host and figure out all the information about a host based off your stuff as you're going along. So we need to go back to presentation so we can talk about some other stuff. And if we have time, we'll come back here. So how does this work? So this is a Metasploit framework plugin. The main sniffer is in the auxiliary tree. It uses the auxiliary sniffer interface in order to be able to gather the packets. It has a series of helper filters, and so we can take a quick look at the helper filters. As I said, these are loaded automatically, and the way that this works is inside the Metasploit directory, there's this data subdirectory that's full of all sorts of things that Metasploit uses for the things that it does. So if we look in exploits, and under pig, there's all of these different files. So to add a new protocol that you want to look at, you create one of these capture files and you just drop it in here. So these are all of the protocols that we can look at right now. One of the things that we do to help speed up the capture, because in some places you're just going to get a crap load of traffic, is we've set some specifications for what types of information you want to be looking at. So the register rules function that this has sets what the criteria are for being able to handle this traffic. The parse method accepts a packet and then uses racket in most cases, which is the packet manipulation modules that are included in Metasploit to be able to break down the packet at each layer to get the different types of information you're looking for. So basically this is the code that breaks down this packet, and then end of the day we report the note information back up. So if there's other stuff for some of these that you find interesting that you want to add and add back in a different way, the report note functionality is what does this. So in order to build a new one of these, basically all you have to do is do a register rules for whatever you're looking for and create a parse. The class has to start with the word pig, and then is the second portion is whatever the protocol is, and we have a pig parser class that has all of the helper functions for this already built. So you can just include that class and all of this code gets pretty simple. And all of this code is on my Subversion repository too. So it's easier just to copy and paste into a new one and start breaking this stuff apart. Racket is very well documented. One of the problems is it doesn't support some of the more complex protocols. So I actually had to write an MDNS parser, which completely sucks. So it's also not completely implemented. I pulled the most common fields out. So if you're looking at some sort of traffic and you know of some really obscure MDNS field that is really kind of awesome, and you want to help me implement it, then that's cool. So let's come back out of here. So these are the currently supported filters, and we're going to talk a little bit about what's in each one. The Cisco Discovery Protocol is designed to help you figure out what your infrastructure is in case you forgot. So that protocol talks back and forth between Cisco devices to let you know what switches are connected on which port, what their OS is and capabilities are. So we can figure out OS version, IP address information, in most cases VLAN information, management information, and all the other stuff that's in the slide. So why this is cool for us is security people. So it's really nice to know what OS version is running in case it's vulnerable. The IP address information is interesting. So we can know what its interface IP addresses are, but more importantly, what its management interfaces are. So if you actually have a company that is protected their management interfaces, you can know what network you need to get onto to be able to manage the switch. VLAN information is interesting. Voice over IP is becoming more and more common in enterprises, and a lot of the time, CDP is really nice about telling you what the voice over IP VLAN is. And that makes VLAN hopping really easy, because at that point, you know the switch is talking CDP, so you start talking CDP, and you say, hey, I'm a Cisco phone, and it'll go, okay, here's your VLAN. And so then you're on the voice VLAN. So basically, it gives away a whole lot of information about both the way that you have protected the switch, as well as what type of hardware and what OS you're running. So it gives you a little bit better view of what's going on in the infrastructure. DHCP informs are interesting. So you may not see the request and you may not see the response, but a lot of the time you will see the informs. And so this is another one where I'm trying to finish it out, but it pulls out the MAC address, hostname, vendor class, and request list. The vendor class and request list is well known to be able to fingerprint hosts to be able to figure out what specific operating system they're running, sometimes down to service pack level. So you can use this to, just based off the DHCP traffic, figure out what OS a host is running without scanning. And these are broadcasted out pretty freely in a lot of environments. So Dropbox is kind of interesting. It really wants to talk to its friends on the network, and caring is sharing. So it will go ahead and tell you it's using Dropbox, and it wants to make sure that you know what the version and the port number it is. So if there's ever a Dropbox vulnerability, it's like screaming, hey, own me. But the shared namespaces is interesting. There was a recent conversation about an attack where if you can acquire someone's config for Dropbox, you have access to their files. So there's a concept called privilege escalation in pen testing, where you get in at a certain level and then you look for the next level to elevate your privilege. And it's essentially an iterative process in order to get to whatever level you want. So Dropbox tells you what namespaces it's using. So say you see the CIO is using a namespace, and that same namespace is in use by someone who is running every protocol known to man. You can go ahead and say, since you guys are using the same namespace, I know you're going to be easier to hack. I can hack you and gain access to that same information that's on the CIO's computer. Well, so, okay, that's kind of interesting. Except for, since you have access to it, you may be able to add to it, which, what better way to do social engineering than drop an email from the person whose machine you just broke into and said, hey, I just added something to the Dropbox. Can you check it out and see what you think? And so you have the ability to look and manipulate that stuff. So while it is not something that can be directly used for attack, it's certainly something that can be leveraged as part of an attack. Groove, which is now like Microsoft Workspace Collaborator, some crap like that, is designed so that you can do peer-to-peer sharing of, I guess, Office documents or something. And it tells you some cool stuff. It tells you whether or not the person is online or offline, which just because the software is running that doesn't mean that someone's directly logged into a workspace. So it'll tell you whether or not they're logged into a workspace. It'll tell you the port. The really interesting one is, for some reason, it feels the need to tell you every IP address that's on the system. So why is that interesting? So say you are on two networks. I will know your other network's IP address. Also know if you're running VMware or any other virtualization software, or if you're bridging wireless and wired. Any of those sort of things can really use to gain additional insight into both the host and the network itself. And it'll also tell us the version. So if a version's ever vulnerable, we can figure information out based off that. But I guess the other interesting thing is different versions of Groove ship with different versions of Office. So I also know what Office version you're running. So if there's a new 0-day for Office 2007, and I know you're running the Groove version from 2007, you're now a target for social engineering. MDNS is the one I talked about earlier. The thing, I guess, that I don't really understand is Apple feels the need to send out a packet listing all of your ports. And I'm not sure how that can be helpful at all. I guess it's designed to help in service discovery on the network so that you can see peers that you can talk to, whether they be SSH servers, gateways, etc. It'll list out IP addresses. Frequently, through the status information, it will give out people's names, whether or not they're actively logged into the machine, and other available functionality information. Printers are using MDNS a lot more now so that you can discover them on the network. And some of the printer stuff is fascinating. You can figure out everything from what the management server URL is for it, whether or not it's protected, whether or not it has a stapler. I guess in case you want to go on a stapling spree. All of that sort of information it sends out in a very well formatted packet, so that you can pull all that information out and you'll know exactly what's on your network. MDNS also frequently will share information about the Windows domain and hostname formatting, and also user IDs. So as you're profiling a network, you can gain additional insight into how the system administrators have set up the network from that. SMB, this has been around for forever, and this is a result of NetBIOS. And so it does send out the host OS version, whether or not it has file sharing turned on, so whether or not the server service is started, and whether or not the workstation service is started. It'll send out its host name and domain name. And where this becomes really useful is, for some reason, I guess SQL Server got included in this list. So Microsoft really wants you to know, broadcast it out on the network when you're running a SQL Server. So if you're looking for a way in, a lot of the time the Microsoft Developer Network SQL Server is very poorly secured. So if you just sit there and listen, you may have just a list of attack vectors come to you and go, hey, come break into me, which as a pen tester is obviously very interesting, but as a network admin is very troubling. Okay. So they still are broadcasting out SMB1 in a lot of cases. So the broadcast package, yes. The actual peer-to-peer communications is SMB v2, and I haven't looked at that. Metasploit has written their own SMB v2 parsers, and the deal with SMB v2 is you're dealing with challenges and responses as part of that negotiation. And as far as the broadcast packets go, since you're just screaming, hey, look at me, there's no need for any sort of nonsense to be involved. Does anybody else have any more questions before I go forward? Okay. So SSDP, which is better known as Network Plug and Play, is absolutely awesome. So I guess that's another one that I find very intriguing. It's easy to discover printers, and for some reason the security cameras are always talking Network Plug and Play. So if you're listening on a network and all of a sudden you start seeing these packets come in, basically they have a little bit of framework information around them, including a URL to find out more. So that URL to find out more is where you get all of the goodies. With the cameras, normally it's the URL to log in and look at what's on the camera, and those sort of pieces of information. For printers, it's where to go to get the printer status page. Also, printer functionality is sent out in the network plug-and-play information. So you get all of this information coming in about gateways. Also, in addition to just the security cameras, a lot of the times people's cameras on their desk now have some of this capability where you can plug it into the network as well. And if it has a network port, why not plug it into the network? So, I mean, you can maybe even be watching somebody at their desk doing stuff for some of this information. But it ships, it sends out a URL to find out more. And so you go to that URL and it gives a whole big set of information, including usually the operating system it's running, what its capabilities are, the URL to manage it, and other things that are neat that you can do with it, going back to the stapler stuff. And a lot of the time the security cameras are really poorly secured, so if you're on a network and you want to know if anybody's in the lobby, you can find out. So we've gone through a bunch of that stuff. So how do we fix it? NetBIOS over TCP, disabling that, which most of the time we're not really needing that anymore. If you need to share files from a friend, you can go directly to their machine name. You don't need to discover them on the network. Most corporate networks have so many nodes that when you try to view my network, it's pretty much just annoying. So for most systems, disabling NetBIOS over TCP is probably the way to go. SSDP, which is the network plug and play, in most cases you don't need it. I guess if you plug into somewhere and the gateway is on a really weird IP and it wasn't given to you via DHCP, it might be helpful in some way, but in most cases it's just not useful. CDP is a tough one because a lot of network admins really love CDP because they don't have to remember where they connected their stuff. You can just type in show CDP neighbors and it tells you where everything is. For most edge devices, you don't really need it. So I would say at the core, it probably is very helpful. As you start moving out to edge devices, you may want to look at disabling that. For DHCP, there's a concept of DHCP helpers, which what DHCP helpers do is when DHCP requests are seen, the DHCP helpers information tells the network, hey, my DHCP server's over here, you don't need to send this crap out to everybody, go here. And so turning on DHCP helpers will prevent a lot of that broadcast information from leaking out. It obviously takes some configuration in a large network. It may be difficult, but it definitely will stop the broadcasting out. So for Dropbox, disabling LAN sync will stop you from broadcasting out all of your Dropbox information. Groove, it's a Microsoft product, and making it stop being noisy is challenging. I haven't found a way. If you find a way, I'd be interested in knowing. Uninstall certainly would be effective. It is a Microsoft product, so it may reinstall the next patch. And then MDNS, so some aspects of MDNS are really nice. I mean, being able to know who other iTunes collection I can look at is obviously cool, and some of that other stuff. I guess step one is when you get your Mac product is change the name. If you don't need it, there's checkboxes in the network and control panel to disable some of this functionality. So uncheck those, and it may not always be an option to actually turn it off, but limiting what information it shares is certainly beneficial. So how to help? I need more data to find more cool stuff. So if you're willing to share some broadcast and multicast traffic, which if you're doing a TCP dump, that makes it easy because you can say for the filter broadcast or multicast. And so that way you're only capturing the stuff that I would be interested in anyway. I need some help working through the data is publicly available, but there's tables out there for IDing hosts based off DHCP filters. And so getting that functionality implemented would be helpful. And also, if you know of more protocols that would be cool and have some packet captures of them, I can help break them down if people can provide me information. And if you really like working with protocols and want to figure out how to add your own, I'm happy to work with you if you'll contribute some of this stuff back. So in the future, what I am hoping to do by DEF CON, and if you guys haven't heard of DerbyCon, you should definitely check that out because it is going to be awesome this year. and I want to try to get some of this pushed into the interpreter. So as you exploit a machine, you can push this functionality directly out so that you don't actually have to be on the network. You can use remote agents to help gather this information for you. So better OSID is coming, more protocols, and I'm going to be writing some helper applications. For some of this stuff, even Andreas isn't easy to manage, but I'm going to release the Python scripts that will help pull this stuff directly out of Metasploit and format it a little bit better. So that's all of the resource information. And does anybody have any questions?
And that's excellent because we're out of time.
Good.
Let's thank Ryan for this great talk. It was fantastic.